Hi class, this is Mrs. Lyons. Today our podcast is very quick, only 2 slides. We're going to be talking about average atomic mass and what that means. So let's get going. Atomic mass is the average of all of the naturally occurring isotopes of that particular element. So remember, in our last podcast, we said that there were 3 isotopes of hydrogen. Hydrogen 1, hydrogen 2, my pen is acting up, and hydrogen 3. Okay, these are the 3 naturally occurring isotopes of hydrogen, and they each have a different mass. Well, it turns out that hydrogen 1 is the most abundant form of the atom in nature. Okay, and then there are smaller amounts of hydrogen 2 and hydrogen 3. And it's the averages of these that give us the atomic masses that we see on the periodic table. So let's see how that works. All right, if we look at carbon, there are 3 naturally occurring isotopes of carbon: carbon 12, carbon 13, and carbon 14. All right, carbon 12, and all of these, if we wrote the correct nuclear symbol, would have a 6 down here because we know that the atomic number is 6. There are 6 protons in each of these. So in carbon 12, there's 6 protons, 6 neutrons, which would give us a mass, protons plus neutrons, of 12, and we use atomic mass units when we're talking about atomic mass. Carbon 13 has 6 protons and 7 neutrons for a mass number of 13 AMU. Okay, notice that this says that carbon 12 is the most abundant form, making up 98.89% of all of the carbon that there is in nature. Carbon 13, 1.11% of all carbon, and then carbon 14, 6 protons, 8 neutrons for a mass number of 14 AMU. This is less than 0.01% of the carbon. So we find this very, very rarely in nature. Now, how do we use all of these numbers to figure out the average atomic mass? If we look at the periodic table, it tells us that carbon has a mass of 12.01 AMU. Where did this number come from? Well, let's figure that out. All right, there that is, 12.011 AMU. If you look at your periodic table, that's the number under this carbon symbol. So what we do, we want to figure out the average atomic mass. So we look, and we need to take the masses, which these are the mass numbers. So carbon 12 is 98.89%. Carbon 13 is 1.11%. And carbon 14, we're going to say is 0.01%. Okay, it said it was less, but that's what we're going to do. So to calculate average atomic mass, what you do is you take the mass number of each isotope and multiply it by the percent abundance. Okay, and you add all of those isotopes together after doing the same thing. And you divide this number by 100, and this is going to give you the mass number. So let's see how that works for carbon. We have carbon 12, so the mass number is 12, and the percent abundance is 98.89. And we're going to add that to the second isotope, which has a mass number of 13, carbon 13, and an abundance of 1.11%. And then the last isotope, carbon 14, with a mass number of 14, and a percent abundance of 0.01. Alright, we are going to add all of those numbers together, multiply, divide them by 100. Let me plug this into my calculator real quick. If I do that, I get let's see. I should have done this earlier. You should be multiplying while you're while we're working on this. You should be multiplying. And then divide by 100. I get, if I plug it into my calculator correctly, I get 12.02. And on these, we're just going to do 2 places after the decimal. The units are going to be AMU, atomic mass units. Okay, so check my math. We will do lots of examples of this tomorrow in class, practicing, figuring out how we get to the average atomic mass on the periodic table. Until then, I will see you in class.